Okay, hello. My name is Katja Niemann. I'm from the Fraunhofer Institute for Applied Information Technology in St. Augustine in Germany. And my talk will be more about the data that we collect about the learner than about the learner themselves. So we already collect a lot of usage data, a lot of social data. We have a lot of information about the students, but normally they are stored in very different formats, and it's really hard to map them or to create a larger databases out of them. So I work for the Open Discovery Space Portal, a project which aims to create a portal where teachers can connect, build communities, and the ODS project also tries to integrate several learning web portals that already evolved in the last years. So, and dissimilar to other projects, we do not only harvest information about the learning object metadata, but we also want to gather all the information that was collected in these portals about social data and usage data. And there are a lot of usage and social metadata formats out there. For example, there's the CAM format, there's the NSDL paradata and NSDL annotation format. There are some specific formats like the organic EduNet format, which was inspired by the CAM and the NSDL format. There's also a paradata format from the learning registry and so on. And as the first study, we investigated 3 data sets and tried to map the data so that we have one data set that we can analyze in a unified way. So the first portal that we analyzed is the MAZE portal, which holds learning objects from the architectural domain, and the usage metadata is stored in CAM. Usage metadata here are clicks like accessing a learning object, rating a learning object, tagging, searching, and so on. Then there's the Learning Resource Exchange portal, which holds learning objects for schools from different domains. The data is stored in NSDL paradata format. And then we also have the Organic EduNet portal, which offers learning objects from the organic agriculture domain, and the data stored in a specific Organo EduNet format. So, and I will go into detail for the formats, because I think this is really important if you want to use them or if you want to map them. The first one is the contextualized attention metadata format, the CAM format. If you know it already, you might wonder how it changed, because we simplified it a lot in the last years, because we want to be able to represent as much events as possible. So the CAM format is event-centric. This means we have one instance for each event. And each event has an event type, for example, access or send or rate. And each event has a timestamp and can have several entities that participate in different roles. So for example, if you have the event send email, you also have 3 involved entities at least. So there's one person involved as sender, there's one person involved as receiver, and there's also an object involved as email itself. Maybe you can also have the email client as an entity, or attachments, and so on. So this is an example in JSON format. Here we have the event type select. And we have as entities the viewer who selected the learning object, we have the learning object itself, and we have also the portal in which the learning object was selected. So now we come to the NSDL paradata, which was developed by the National Science Digital Library, and it's not event but object-centric. This means we do not have one instance for each event, but we have one instance for each object, one paradata record for each object. And each paradata record holds exactly one usage data summary, which contains all events conducted on that learning object. It's important to mention that the NSDL paradata was not designed to store single events, but aggregated events, so we do not have any user information. And we have 5 different elements to store the events, and I will give you some examples for that, because then it's easier to understand. So the first integer flows is an element if you want to state how many times a certain event was conducted on a learning object. So here we know that in February 2011, the learning object was viewed by 36 educators from high school in mathematics. So for the string represents events like tagged, like commented, and here we also know, okay, this learning object was tagged 2 times with the term fractions. The rating is pretty clear, I think, but we can have several ratings. It's not only good, but here we have the rating time usability. We also can have a type like the quality of the metadata or the suitability for a specific course. And we also have the min and the max values. So here, 56 teachers rated the learning object for usability on a scale from 1 to 5, with on average 4.5 stars. So for the vote, we also have different types, and vote just means thumbs up or thumbs down. And here we have the type useful, so 10 teachers said, yeah, the object is very useful, and 4 teachers said, no, it's not useful at all. So and then we also have a rank. This is here the rank for most useful, and the best is 1, the worst is 5, so 5 learning objects were ranked, and this learning object is on rank 2. So you can see that the NSDL paradata, it was really created to exchange usage metadata. So we don't have any usage and user information, and it's also very restricted. So CAM is much more flexible and open. You can store more data. You can really store all events you want to store. But you always have a project-specific vocabulary, which you don't have here. NSDL is very restrictive. So, and then we have the organic internet format, which, where the XML binding is inspired by the NSDL paradata. So it is object-centric as well, but we store single events. So the user information is given as user ID. Yes, and we have it for strings. So at the moment, we can store comments, and we can store tags, and also ratings from different times, different dimensions. And I don't give examples here because I think it's pretty straightforward if you have seen the NSDL examples. So now we want to transform the metadata instances to have one data set that we can analyze. This is not so straightforward. At the beginning, when we started, we thought, okay, we can just create one XSLT file for each transformation, and this will work, but it doesn't. When you want to transform CAM to organic IDUNet, you really need, or also if you want to transform it to NSDL, you really need to have a look not only at the elements and rearrange and reorder the elements, but you need to investigate the types, the values of the elements. So, for example, because NSDL and organic IDUNet are object-centric, we need to consider the role. And whenever we have an event that we want to consider, which is in this case rate, tag, and comment, we need to see if we have an entity with a role object or item, because then we need to create one organic IDUNet instance. It's more straightforward to transform NSDL to organic IDUNet because it's quite similar in its structure. We only consider the string and the rating elements. We do not consider integer, vote, and rank because this is not supported currently by organic IDUNet. We do not need the total attribute. So we need to decide if we have this information that a learning object was tagged 2 times with the term fraction, we can say, okay, we want to have this in organic IDUNet as one instance, or we want to have 2 instances which are basically the same, but it was done 2 times, so we want to have it 2 times. This is something that needs to be decided depending on the purpose of the matching. Okay. Then we did some very first analysis. So first, you can see some basic attributes. The MACE dataset holds 76 users, while the organic internet holds 162 users. For the learning resource exchange dataset, we don't have any information. And we created 2 datasets. Out of this, we merged these 3 datasets, and we created one dataset, the dataset A, containing the events from MACE and organic internet, because here we have user information. And we also created a dataset B, which contains all events from all datasets, but without any user information. So, and then we analyzed it. It's just a really basic analysis for the beginning, based on the skewness and on the Gini. I don't know if you're familiar with these measures. I will explain them shortly. The Gini measures the concentration of the rating frequency distribution. This means if each item has, for example, exactly 2 ratings, the ratings are distributed very equally. So we have a Gini of 0. And if the item ratings are distributed very unequally, then we have an item Gini near 1. And for the skewness, here we calculate the asymmetry of the user's rating frequency or the item's rating frequency distribution. And here it is basically the same. The bigger the value, the less equal is the distribution. And here we can see that, in most projects, we really have some items that are rated a lot and a lot of items that are rated not so often, maybe just 1 or 2 times. And if we combine these data sets, we just more or less average these values, because in the data sets that we merged, we do not have overlapping users or items. Okay, so my conclusion. There's no one-size-fits-all solution. So if you want to map one format to another to get a bigger data set to support your users, you really need to investigate the domain. And what we did for the Open Discovery Space project is that we created another new format, because we thought, okay, we create one format that can contain all the values that are contained in the different data formats that are already existing, so we can map all these other formats to our new format, which is just less work. And in the future, we really want to go deeper in the resource and user disambiguation, because at the moment, even if 2 objects are the same, they often have different IDs when they come from different portals. And we want to investigate that, because the mapping and merging can only be really helpful if we can find these. And we want to do some more experiments with the data sets, real experiments, and see if we can enhance recommendations, for example. That's it. Thank you. Any questions?
I have a question with the harvesting process. So you have like different data sets. So how often is this harvesting process done, and where does this data reside?
The harvesting is done really once a day, but it's an incremental harvesting, so we only harvest new information and not the old information. And we have one central repository where we store all this information.
And one more. How can this be incorporated into, for example, for educators, that they can use this as a way for, I would say, like in two ways. One is to find relevant materials that they can incorporate in their classrooms, or for creators of content to really market their resources.
I think at the moment we have a lot of very interesting learning analytics tools, which we already saw, but you only can use them if you have your data in that specific format. And I think that's a challenge, to create one format where we really can use all the tools for all collected data sets. And this is also a chance for the educators. Okay, thank you.
All right, so we thank our speakers, and it's break time. Thank you.